So thank you for having me. The first thing I would say is to give you an idea of who I am. So I'm stuck with the cochlear implant. I'm the first generation student because neither of my parents went to university. I'm also the first in my family to study for a PhD. Now I went to the University of East Anglia to do a master's in natural sciences, so I did maths and physics, and I graduated in 2017. After that, I was working for a startup in Cambridge for a year doing market and business research, but I wasn't happy. So I decided to apply for a PhD in maths at Cambridge in 2018. I started, and now I'm in my third year. My research is in the direction of sound waves with abstract or acoustic and acoustics. Really very because I'm deaf about hair anything, but my research is in sound waves. To give you an idea of my research, what I do is I study tangible physical problems that we see in the real world around us. So to establish, the first is looking at the hulls of underwater vehicles to see how we can reduce the noise emission. And I know somebody who is working on improving the efficiency of vacuum cleaners. But the issue is that it's often too difficult to solve the equations directly. So what we do is we make simplified assumptions to make the problems easier to solve. And we keep making assumptions until we can't solve it. And when we do that, we got to get understanding of the problem so that we can use the solution to do these like design better materials and so on. To give you an example of my research, I'm going to talk about a famous problem in acoustics that this was proposed by somebody called Sommerfeld, who had this question of if we have a semi-infinite bar, which is this bar here, and we send a sound wave to it, how does the sound waves scatter or come back up the bar? So this is a math idea of what the sound waves will sound like if you come up the bar. And this is exactly what I work on for different objects and shapes. Now, it's difficult for me to know how to tell you what I do in my research without having the knowledge of it. But much of my research and everyone in maths boils down to solve the equation. And one idea that I use in my research is that the called asymptotic expansions, which allows us to solve an equation approximately. The idea is that if we have an equation, it could take a long time to solve it. So what we do is we approximate the equations and we solve that to within the desired precision, and that is often much faster. The reason that is called asymptotic because each the solution to the equation will be a series of points. And as you go down the series, each point is going to be much smaller than the before. And to highlight this, and we're going to talk about how to compute the square root of 10. Thus, it goes to define a numerical value, but the square root of 10. What we do is we first look at a number that is close to 10. And this could be 9 or 16, but here 9 is closer to 10 to 16. But we're going to use 9. And we know that 9 is the square of 3. So what we do is we write square root of 10 as the square root of 9 plus 1. Then we take out the factor of 9 outside. So this is exactly the same as this, but we move the 9 out. Now we know the solution to this is 3, but this term is more difficult to solve. So now the question is, how do we solve this? And I hope to see this, but we're going to use the binomial theorem that is done the square root. So if you recall the theorem, is that if you have a term of this, they can write it as a sum of powers of x. This is exactly the same as this. But here, for our example, with the n is a whole because this is the square root. And here, x is going to be 1 over 9. So what we do is we're going to put these two terms in this term. So we're going to calculate the first 4 terms. So we've got 1, 2, 3, 4. So when we do this, we're going to get these 4 terms, and the first these, we're going to see this sign. And this means it's not exactly the same. It's approximately the same. And the second thing is that if you write these terms in this form, you're going to see that this term is much smaller than this term, and then this term is going to be even smaller than this term, and so on. So that we end up with this term. And the idea that each term is smaller is the clear idea of the asymptotic expansion. And this is a simple question, but it is exactly the same ideas in my research to solve very difficult equation. Now, if we go back to our problem of the square root of 10, we've got this is going to be approximately equal to 3 times this approximation, which is this. Now, if you do this on your calculator or at the computer, the calculator will tell you that this is going to be equal to 3.1622776, and the difference is really small, so we don't have to have many terms to find a good approximation to this equation. Now, what we did was, this was done by hand, but in practice, everybody will do the research on computers, and the online languages such as Python, Cochlear, MATLAB, and Mathematica. I can write a couple of codes in Mathematica to find the approximation and to compare with the exact answer as a plot. So if you look, the x-axis is how many times we got in the expansion or square root of 10. And the y-axis is the relative error. So the smaller the error is, the better an approximation it is. And this is the first time that you can see that it is got a very big error. But if you think the second time, you can see the second time that have a much smaller error. But then the third, the fourth, and the fifth look exactly the same. The difference is so small that you could stop at the third and it would be the same as the fourth and the fifth. So the key point of this talk was, if you're doing research in maths, we're going to be using approximations to solve equations approximately a lot, because it's faster the value that it's that solution, and it's usually good enough for writing papers. And there are many methods, but one that we use is asymptotic expansion. And we saw an example of an expansion using the binomial theorem to approximate the square root of 10 by hand. But normally the process get this to the computer and tell it the calculated value. So yes, that's it. If anybody has any questions, I'll be happy to answer them.